Hello there, it's Jake, and we're going to be going over dynamic secrets next. So let's talk a little bit about what this means. I actually misunderstood this the first time I learned about dynamic secrets, and when I learned what it was, I thought this is really cool. So unlike KV secrets, where we had to put data into the store ourselves, dynamic secrets are generated when they are accessed. Pretty cool, huh? So like dynamic secrets do not exist until they're read, so there's no risk of someone stealing them or another client using the same secret. And because Vault has built-in revocation mechanisms, dynamic secrets can be revoked immediately after use, minimizing the amount of time the secret existed. So for this one, we're going to be messing with AWS, so make sure you have an AWS account. We're not going to be using anything that costs money, so don't worry about it. Plus, all of my Terraform and my Packer and now Vault, I have yet to incur any cost with anything that I've built, so if that makes you feel any better. So let's go ahead and enable the AWS secrets engine. It has to be enabled before you use it because KV just, like I said, the type, it just exists. So we have to enable this first. So Vault secrets enable dash path equals AWS. So the AWS secrets engine is going to be enabled at the AWS path, as you can see there. And different secrets engines allow for different behavior. In this case, the AWS secrets engine generates dynamic on-demand AWS access credentials. So now we can configure the AWS secrets engine. After enabling the engine, you have to configure it to auth and communicate with AWS, which requires privileged account credentials. I already have my AWS account credentials set, so make sure you export your access key ID and secret access key on your local machine, and you can do that with exporting variables, or you can just type AWS configure if you have AWS CLI installed. All right, so let's go ahead and get this set up. So we're going to do US East 1. And I'm going to just paste this in. Vault, write AWS config / root, my access key, my secret key to region US East 1. And it's been written to AWS config root. Sweet. So now these creds are stored in the AWS secrets engine, and the engine will use these creds when communicating with AWS in future requests. Pretty simple. All right, so let's create a role. The next step in configuring a role, Vault knows how to create IAM user via the AWS API, but it does not know what permissions, groups, policies you want to attach to it. So this is where the role comes in. It's a human-friendly identifier to an action. So let me just make an example here. So if I made a file, test. I don't even know what to make this. TF. It looks like HashiCorp language. It could be JSON. Let's do JSON. Rename. JSON. More people familiar with it. All right. So here's our version, our statement, statement ID, an effect allow, action EC2, resource boom. So this looks a lot like an IAM policy, right? Because this is an IAM policy. So if you're not familiar with IAM policies, that's fine. You can kind of get the drift from this, but I highly recommend going and checking it out. Once you start getting into security stuff, you're really going to need to know IAM. We need to map this document policy to a named role. So to do that, we are going to write to AWS roles where we use a unique name that describes the role. So in our case, let me see if I can put this in here. I could do something like this. Vault write AWS roles, my role, credential type IAM user, policy document, end of file, end of file. And then I can just run this. I should be able to just stick this in my terminal. And that should just work. And that'll give us a role for an IAM user. Bam, done. So even my role now is a secret. So what I just told Vault was, hey, when I ask for a credential in my role, create it and attach the IAM policy of this. So even that is ephemeral. So now let's generate a secret. So let's do well, at least now that we have it enabled, we can configure a role. We can ask Vault to generate an access key pair for that role by reading that AWS creds name, which is super handy. So let's check this out. Let's do Vault read AWS creds my role. So again, this doesn't exist right now. So because I'm trying to read it, it's creating it, which is why this takes a little bit of time. And there you go. This is all encrypted and all that other stuff. We have, let me check. Sweet, so this worked. The creds that you're looking at, if you're like, oh my God, that's your access key and secret key. Not actually true. The access key and secret key can now be used to perform any EC2 operations, is what I allowed them to do, right? Up here, action, EC2, effect, allow, resource, any. And it gave me a unique key. So these keys are different. And if I were to run this command a second time, I would get another key pair. And I'll just show you that right now. Let's go ahead and prove it. And the idea is it's generating this every single time. So I'm not actually getting, yeah, see, look at my secret key and my access key are completely different. So this is a great way to obfuscate that from anything. So each time you read from AWS cred and then whatever the name is, in this case my role, Vault will connect to AWS, generate a new IAM user and a key pair. So we're going to copy the full path of the lease ID found in our object. So this guy right here, this full path, I'm going to copy that. This value is used for renewal, revocation, and inspection. So we can revoke the secret if I wanted to, and Vault will automatically revoke this credential after, like, I think it's 768 hours. That's the lease duration, but that's in the output. Yeah, there it is, lease duration. There you go. But maybe you want to revoke it early. Maybe you had a contractor or somebody quit or whatever, somebody got fired. Once the secret's revoked, the access keys are no longer valid. So all we need to do is vault lease revoke. So I can do vault lease revoke and then pass this entire path with all the algebra at the end of it. And then boom, I can revoke this and the lease will be revoked. So now if you log into your AWS account, you can see that no IAM user exists. If you try to use the access keys that were generated, you'll find they no longer work. So let's go ahead and check this. Let's make a, let's see, and that one. Let's read this. And then while it's reading, I'm going to open a browser, aws.amazon.com, and then I'm going to sign in. And I was already signed in, so I don't need to use MFA. And I'm just going to go to IAM. And I should only have one user, and that's myself. But you'll see here, I actually have 3 users. So I have these 3 vault roles and these IDs, which is kind of cool, right? So now if I wanted to, I could revoke this and just say vault lease revoke that, and it will remove that IAM user. So we're basically working dynamically and creating users dynamically with the creds that we need. Instead of creating a user for a person, it creates a user for a specific instance of authentication. Pretty sweet, huh? All right, so we've got one other user in here. Let's go ahead and take a look at this one. And that one was the first one that I made, which is this guy. So let's revoke this one. Vault lease revoke splat. And that will have cleaned up all of my Vault AWS IAM users. And let's verify. We can see that in the logs of this server that I have open in an interactive session. Where is my, there you are. Refresh, and boom, they're all gone. pretty sweet, huh? Okay, so this is the first dynamic secret that we've created. It's kind of cool to know that they're not actually created until they're read, and you saw the revocation system. This is an incredibly powerful tool. The dynamic secrets database secrets engine tutorial demonstrates another version of dynamic secrets engine that we're going to get into. Before we do that, we're going to go through some built-in help systems. So I hope you had fun and go create some stuff.